You need to use the periodic table to find the oxidation numbers for each element. So make sure the periodic table is handy. So looking at this first example, what we need to do, I'm going to follow the directions. Direction number 2, write the element. The positive ion is always written first. So looking at the 2 elements on example 1, we have lithium and bromine. Lithium is positive 1, bromine is negative 1. You were supposed to have written down the charges that we gave you in class. So if we look in the column of 1A, lithium is found in 1A, it has a positive 1 charge. Bromine is found in 7A, it has a negative 1 charge. So looking at number 3, it says crisscross and reduce the oxidation numbers. For this particular example, what we are basically trying to do is balance these oxidation numbers out. So I look at the oxidation number on lithium and see that it is a positive 1. The oxidation on bromine is a negative 1. So these charges are already balanced. So the formula would be just LIBR, 1 of each. Now the compound name. Direction 5, when naming your compound, the ION gets the IDE ending and is written second. So for example, looking at bromine, the anion always gets the ending of IDE. This is always true for binary compounds. Binary means 2 elements in the compound. Okay, so let's look at example 2. Number 2 says potassium and iodine. So look on your periodic table, find potassium. Potassium is found in group 1A, has a symbol of K, and it has a positive 1 charge. Find iodine. In group 7A and has a negative 1 charge. So I look at my charges, and my charges are balanced, +1, -1. So that means I only need 1 of each. So I'm going to write Ki for my formula. Now to name this, following the example of the first one, you name the first element. So I would just say potassium. So your second element is iodide. All right, pause the podcast, and I want you to try number 3 on your own. I am going to continue, though. Follow the same way that you have been doing it. Hydrogen is a +1. Phosphorus, you find it on your periodic table in group 5A. Symbol P has a -3 charge. The charges are not balanced, so what we need to do to get these balanced is to add more hydrogen. So I would have H3P. So I have 3 total hydrogen. Each of them have a -1 charge, so my total positive charge is +3. Let me go on to another page to show you this. Hydrogen has a +1 charge. Phosphorus has a -3 charge. You need to balance your charges. So I am going to bring in 2 more hydrogens, each having a +1 charge. So my total number of hydrogens, I have 3 of them. It took 3 for me to get a +3 charge. So when you write the formula, you have H3, and then we only had 1 P. All right, going back. Now naming it. You name it the same way we've been naming the other ones. You list the name of the first element, so I would say hydrogen. And then the last element gets the IDE at the end, so phosphide. All right, number 4, sodium is Na. Sodium's in group 1 as well, has a positive 1 charge. Nitrogen is in group 5A, has a negative 3 charge. This one looks very similar to number 3 that we did. Looking at the charges, to balance them, I would need 3 sodium for every 1 nitrogen. Now naming them, it would be sodium, and then nitrogen would change to nitride. All right, number 5. Magnesium is Mg. Magnesium is found in group 2, so it has a positive 2 charge. And we are mixing it with fluorine, and fluorine has symbol of F. It's found in group 7A, has a negative 1 charge. Charges are not balanced, so for me to balance the charges, I need to get another negative 1 charge to make it negative 2. So because I'm bringing in another fluorine, I use the subscript 2 to say that I have 2 of them. All right, let me go on the next page and show you again. Magnesium has a positive 2 charge. Fluorine has a negative 1 charge. We want our positives and negatives to balance out. So to do that, I have to bring in another fluorine that has a negative 1 charge. So total, that is a negative 2 charge. Plus my positive 2, those balance out. So I have 2 fluorines. So we would say the compound is MgF2. With ionic bonds, we are trying to balance charges. All right, going back. I want you to go ahead and try the next 3 on your own, and then come see me to check if you're doing it correctly. All right, I'm going to scroll down to the bottom, this bottom chart. All right, now we're going to do it a reverse way. You are going to write the oxidation numbers and the name of the compounds. Try to do this without looking at the periodic table. It gives you the symbol. So Ba and F. I have 2 Fs, so I'm actually going to write out the 2 Fs. So we're trying to figure out what the charges are to get them to be balanced. The first element is always positive, the second element is negative. So since we have 2 Fs, I'm going to say each of them are negative 1. So barium would have to be a positive 2 charge. So if we look at the periodic table to check our answer, barium should have a positive 2 charge in group 2, and fluorine should have a negative 1 charge in group 7. So we would name it barium fluoride. All right, number 4 is very similar to number 3, so go ahead and do that one. Let's look at number 5. Number 5, we have 2 potassiums and 1 sulfur. The first element's always positive, the second element is negative. Since I have 2 potassiums, each of them must be a positive 1 charge, and then sulfur must be a negative 2 charge so that we can balance out those charges. So go to the periodic table, check. Okay, potassium is in group 1, so it does have a positive 1 charge. Sulfur's in group 7, so it does have, or excuse me, group 6, so it does have a negative 2 charge. So go ahead and try the next problems on your own, and then come see me if you're having any issues. So that concludes the podcast on this worksheet on naming binary compounds.